Welcome to the Deep Dive. Today we're exploring something pretty amazing about our brains. The idea that, well, it's not fixed, not static at all.
Exactly.
It's constantly reshaping itself, adapting. And here's the really empowering part, right? You can actually guide that process throughout your entire life.
That's the core of it. This incredible ability is called neuroplasticity.
Neuroplasticity. And it has these huge implications for how we learn, how we remember, how we adapt to, well, everything.
Absolutely transformative implications.
So our goal in this deep dive is really to pull out the key insights from the sources you've provided. We want to show exactly how you can harness this power.
Yeah, make it practical.
Right. Now, many of us kind of know some ways to boost brain power. Things like, learning a new language.
Or picking up a musical instrument. Those are common ones.
Yeah, or even, and this was interesting in the sources, using a sauna. Apparently, it stimulates BDNF.
Brain-derived neurotrophic factor. It's crucial stuff for building new nerve cells, new connections.
Wow. And the sources even mentioned binaural sounds.
Yeah.
Different sounds in each ear promoting plasticity.
That's another area being explored, yes. Less mainstream, maybe, but mentioned.
But let's be honest here. These methods, while they sound great, they often have a downside.
Yeah. The commitment.
Right. They can demand a lot of time or money, or you need specific access. Like, well, a sauna.
Not always feasible for everyone's daily life.
Exactly. So the mission for us today, the real goal of this deep dive, is to uncover 5 strategies. Simple ones, affordable ones, accessible strategies that anyone, anywhere can use to enhance their neuroplasticity, all based on the material.
Things you can start doing right away.
Okay, let's unpack this. But first, to really get why these strategies work, maybe we should lay the groundwork. What is neuroplasticity fundamentally? Why does it matter so much?
It's a great starting point, and it's fascinating because the term plasticity itself, referring to behavior being modifiable, it actually goes back to 1890.
Wow, really? That far back?
Yeah. And even then, Santiago Ramon y Cajal, the Nobel laureate, he proposed that these changes in behavior must have some kind of physical, anatomical basis in the nervous system.
So he suspected the brain structure itself could change?
He did. But, for quite a while after him, the prevailing view became much more rigid. The idea was that the adult nervous system, once developed, was pretty much set. Except for, decline or degeneration.
Ah, the old you can't teach an old dog new tricks sort of idea.
Kind of, yeah. But thankfully, that view has been completely overturned. Starting around the mid-20th century, research just kept revealing that actually the nervous system maintains its ability to change, functionally and anatomically, throughout life.
That's huge.
It is. Today, it's just widely accepted. Our neural networks are constantly remodeling themselves, and this isn't just like a neat feature, it's absolutely vital for how we adapt and survive.
Okay, that makes sense. So when we say neural plasticity, you mentioned that term. Is that exactly the same as neuronal plasticity? Or is there a subtle difference? What parts of the brain are we talking about here?
That's a really good question, and there is a key distinction. Neural is the umbrella term. It covers all the cells in the nervous system, the neurons, and the glial cells.
Okay, so not just the neurons.
Right. If we just said neuronal plasticity, we'd only be talking about the neurons themselves changing. But the bigger picture involves both cell types working together.
Got it. So tell us about the neurons first. What's their role in this?
So neurons are like the brain's communicators, highly specialized cells. Think of them maybe like little starfish with lots of branching arms. They receive signals, they send out messages.
And there are billions of them, right?
Tens, even hundreds of billions. They connect at junctions called synapses, forming these incredibly complex circuits pathways for nerve impulses. And plasticity affects, well, it influences the number of neurons, their types, and crucially, how they connect and communicate. This is what allows us to form memories, learn new skills, adapt to signals from outside or, changes in our own lives, and even recover from injuries.
Okay, so they're the message carriers and circuit builders. What about the other tech, the glia? You said they were important too.
Hugely important. Glial cells, or glia. Historically, yeah, the name comes from glue, and people thought they just sort of held the neurons in place, a very static view.
But that's outdated.
Completely. We now know, really since the late 20th century, that glia and neurons are a functional unit. They work as a team. Glia create the whole microenvironment that neurons need to function properly. They provide nutrients, they help manage neurotransmitters, they even perform a kind of natural cleanup or detoxification.
Wow, so they're like the support crew, making sure the neurons can do their job effectively.
Exactly, a very active support crew.
So putting it together, it's the changes in both the neurons, their connections, their activity, and the glial cells supporting them that really defines this neuroplasticity. That's the basis for how we adapt.
Precisely. It's a dynamic interplay. And understanding this isn't just theoretical, It has very concrete, practical benefits in your everyday life.
Okay, let's connect it. How does this play out for us?
Well, during development, obviously it's fundamental, generating all the necessary cells and connections, pruning back ones that aren't needed. But importantly, this continues into adulthood.
So it doesn't just stop after childhood.
Not at all. In adults, plasticity is what preserves our ability to learn, to remember. It's behind our capacity to regenerate nerve cells and connections. Think about how reinforcement works, positive or negative, that's plasticity shaping circuits. Or how, maybe sadly, memories we don't access can fade, the circuits for them can weaken or atrophy.
That makes sense.
It's also vital for repair on a small scale. Like if tiny blood vessels, capillaries, get blocked or rupture, plasticity helps the brain reroute and recover function.
So a more plastic brain is essentially a more resilient and adaptable brain.
That's a great way to put it. A nervous system with a greater capacity for this kind of modification and regeneration, basically. Greater plasticity just gives you an adaptive edge. It means better learning, better memory, better ability to cope with change, qualities that, well, nature tends to reward.
Right. If we connect this to the bigger picture, it sounds like evolution favors plasticity.
You could definitely argue that. Adaptability is key to survival.
This really drives home how much influence we potentially have. If we understand this power, we can actually cultivate it.
Exactly. That's the exciting part.
Which brings us perfectly to the core of this deep dive. How do we do it? What are these simple, accessible strategies the sources mentioned?
Okay, let's get into them. Here's where it gets really interesting. The first one is learn new things.
Okay, like the language or music we mentioned.
Yes, those are great examples. But the sources really emphasize that you don't have to make such a huge commitment. We have incredible access now to books, audio, videos on almost any topic imaginable. The key is choosing something different, something outside your usual routine or expertise.
So break the mold a bit.
Precisely. Engage your brain in novel ways. Do puzzles, play strategy or ingenuity games. Another interesting suggestion was to mimic people who do something you admire, watch and try to copy the movements of an athlete, an artist, a dancer. It engages different neural pathways.
I like that. Okay, what's strategy number 2?
Number 2 is super important and maybe more familiar. Move your body every day.
Ah, the BDNF connection again.
Exactly. Physical activity directly stimulates the production of that brain-derived neurotrophic factor. BDNF is like fertilizer for your brain cells, promoting new growth and new connections.
Does it matter what kind of movement?
The sources suggest a variety is good. Strength training, playing a sport you enjoy, dancing, just going for a walk. Even, actively using household chores as a way to move your body counts. The point is regular physical activity.
Okay, move the body. Makes sense. What's number 3?
Strategy 3 is about your environment. Explore new paths.
Literally.
Yeah.
Like take a different route to work.
Yes, literally. Break your physical routines. Take streets you don't normally use. If you walk the same route every day, try walking on the other sidewalk. Or finally go visit that park or museum in your own town that you've been meaning to check out for years.
Why does that help?
It forces your brain out of autopilot. It has to process novel environmental information, engage different spatial mapping circuits, make new associations. It's a simple way to provide new stimuli.
Simple but clever. Okay, strategy 4.
Number 4 is see with new eyes, or basically change your perspective.
That sounds a bit more abstract. How do we do that?
It can be quite literal too. The sources give a great example. Changing where you sit. If you're in a classroom, a meeting, even just a room you spend time in, consciously choose a different spot than usual.
How does changing my seat help my brain?
Because even though the input might be similar, the same room, same people perceiving it from a different physical angle forces your brain to process that information using different neural zones. It receives the stimuli differently. This encourages the activation and differentiation of cells in those new areas, forging new connections. It's another way to nudge the brain into creating new pathways.
Fascinating. Just shifting your physical viewpoint.
Yeah.
All right, what's the 5th and final strategy?
The fifth one is a fun challenge. Use your non-dominant hand.
Ah, I've heard of this one. So if I'm right-handed, try doing things with my left.
Exactly. Or vice versa if you're left-handed. Try it for everyday tasks. Writing a note, maybe drawing something simple, typing a text on your phone, using the computer mouse, doing chores like stirring or cleaning, combing your hair, brushing your teeth.
That sounds difficult.
It is, and that's the point. The sources even suggest trying a bigger challenge. Dedicate a whole day or even part of a day to doing everything with your non-dominant hand.
Wow, a whole day.
Yeah, think about it. It forces your brain so far out of its comfort zone. It absolutely cannot rely on those ingrained automatic neural circuits. It has to forge new pathways, activate different areas, really work to coordinate movements differently. This strongly promotes new cell development and new connections.
I can imagine trying to open a can or throw a ball with my left hand would be interesting.
Or sewing. Anything requiring fine motor control becomes a major brain workout when you switch hands.
These really quite remarkable when you lay them out like that. These aren't huge life-altering changes. Learning something new from a video, taking a different street, changing your seat, brushing your teeth with the other hand. These seem like such small gestures.
They seem small, but they're consistent nudges. Actively seeking novelty, intentionally breaking routine, gently forcing your brain to work in slightly different ways. This is what stimulates that new cell differentiation, those new nerve connections. It helps you develop your full neural potential.
And developing that potential, as you said earlier, can lead to being more adaptable, maybe more creative.
And potentially happier, more resilient throughout our lives. It's about maintaining that cognitive flexibility and capacity for growth.
This whole deep dive, it really makes you reconsider your daily habits, doesn't it? We've talked a lot about neuroplasticity, and the core takeaway seems incredibly powerful. It's not just a scientific term. It's this innate, lifelong ability we all have to literally shape our own brains.
It's not fixed. It's a dynamic process.
It reminds me of what you said about Ramon y Cajal earlier.
His idea, yeah, that we can truly be, in his words, sculptors of our own brains.
Sculptors of our own brain. I love that. Working towards our best mental, maybe even emotional selves. It's an ongoing project.
An ongoing potential, always there.
And maybe the most profound message from all this, from the sources, is just how accessible this is. This incredible power to shape your own mind doesn't require, a fancy lab or tons of money.
No, it's available through simple, conscious, everyday actions. Just a willingness to engage with your life, with the world, in slightly new ways.
So as you, our listener, go about your day after hearing this, maybe pause and consider, what's one single small new thing, a new perspective, a new path, a new small skill, even using your other hand for a minute, what small action will you try today? How will you start sculpting your brain towards its best version?